Ready for a deep dive?
Always.
This one is literally out of this world.
Ooh, I like where this is going.
We're talking planetary motion.
The stuff that has had people staring up in wonder, like, forever.
For millennia. You know, it's just amazing to think that for the longest time, like, we were totally convinced that everything revolved around us.
It's more than amazing.
Right.
It's understandable. I mean, think about it. That Earth-centered view, the geocentric model, that wasn't just a scientific theory.
Right.
It was, like, woven into how we understood, well, everything.
Totally.
The universe, our place in it, even, religious beliefs.
It's like, look up, and it just feels like we're at the center of it all, right?
It's intuitive.
So how did we go from that seemingly obvious truth to what we know now? That's what we're going to be looking at today.
It's a wild ride.
We're going to trace that evolution of thought, and we've got some fascinating sources to help us.
We do.
Ancient texts, scientific papers, historical accounts.
The good stuff.
The good stuff.
Yeah.
Our mission, to see how our understanding of planetary motion has completely transformed over time.
And it's not just about, like, rearranging the sun and the earth on a diagram.
No.
This was a total upheaval in thinking that impacted science, philosophy, religion.
Whoa.
It redefined humanity's place in the cosmos.
Okay, so rewind with me. Way, way back to the ancient civilizations.
Okay.
Like, picture these early sky watchers.
I'm picturing them.
They were so dedicated, so carefully tracking the movements of everything up there.
Yeah.
And they noticed, like, the stars, they seemed fixed,
Right, like a backdrop.
Yeah, a backdrop. And then the planets, they were wandering across the sky. So, from their perspective,
Makes sense.
it made perfect sense for the Earth to be the center of it all.
It does.
Right.
And that intuitive view led to some pretty detailed models, like the Ptolemaic system,
Okay.
developed by the Greek astronomer Ptolemy in the 2nd century AD.
So
Ptolemy. Now, his model was incredibly intricate. I mean, he used the system of circles within circles, called epicycles, to try to explain how the planets move.
circles within circles.
Sounds a little complicated. It was, but here's the thing. While Ptolemy's system was ultimately wrong, about Earth being the center,
Right.
it was surprisingly accurate for its time.
Really?
It could actually predict planetary positions pretty well.
Wow.
It was even able to account for things like retrograde motion,
Retrograde motion.
which is where the planets appear to move backward in the sky for a bit.
Wait, planets moving backwards?
Yeah.
How do they explain that with an Earth-centered model?
Well, that's where those epicycles come in.
Okay.
Ptolemy, he added these little loops to planetary orbits
Okay.
to try to account for that apparent backward motion. It was like a complex workaround, but it worked well enough to be the accepted model for over 1,000 years.
Over 1,000 years.
Yeah.
Wow. But even the most intricate systems have their flaws, right?
Absolutely. Over time, as astronomers made more precise observations,
Yeah.
they started to notice that the Ptolemaic model didn't always quite match up with what they were seeing in the sky. It's like having a puzzle where a couple of pieces just don't quite fit.
So what happened next? Did those misfit puzzle pieces make people completely abandon the Earth-centered model?
Well, not immediately, but these inconsistencies started to plant those seeds of doubt,
Okay.
And it was actually during the Islamic Golden Age.
The Islamic Golden Age.
Yeah, this period of incredible intellectual and scientific flourishing,
Right.
that some of the most significant challenges to Ptolemy's model emerged.
Oh, interesting. So we're going from ancient Greece to the Islamic Golden Age.
It's fascinating.
Yeah, I never really made that connection before.
It's a cool chapter in the story of astronomy. Scholars in the Islamic world, they were translating and studying Greek and Roman texts,
Including Ptolemy's work.
including Ptolemy. But they weren't just passively absorbing this knowledge, they were actively critiquing it,
Oh, wow.
conducting their own observations and even inventing new astronomical instruments.
So they were really pushing the boundaries of what was known, even back then.
Exactly, and that's where figures like Al-Tusi and Al-Biruni come in.
Okay.
Brilliant scholars who made really significant contributions to astronomy. For instance, Al-Tusi.
Yeah.
He developed this mathematical technique that could explain planetary motion without needing Ptolemy's equant,
Okay.
which was this point that was off-center from the Earth.
Right.
This raised serious questions about, the very core of that Earth-centered system.
So they were starting to, poke some holes in Ptolemy's model.
They were, and Al-Biruni, another incredible thinker, even questioned the idea of an unchanging, eternal universe,
Whoa.
which was a pretty radical concept at the time.
Yeah, it was.
He suggested that celestial bodies might actually be subject to change and decay, just like things here on Earth.
So were these Islamic scholars the ones who finally dethroned the Earth-centered model?
Not quite, but their work, combined with the rediscovery of ancient Greek texts in Europe, contributed to this growing sense that the Ptolemaic system wasn't the whole story.
Yeah.
The stage was set for a major paradigm shift.
All right, so we've got these cracks appearing in the Earth-centered model. What happens next? Someone finally comes along and puts the sun in its rightful place.
You guessed it, and that someone was Nicholas Copernicus. In the 16th century, he proposed this revolutionary new model, the heliocentric model, which placed the sun at the center of the universe with the Earth as just another planet orbiting it.
Copernicus, I feel like I remember that name from like high school science class, but I honestly can't remember what he actually did.
Oh, he did a lot. His
Yeah.
book, De Revolutionibus Orbium Coelestium.
Try saying that 5 times fast.
I know, right? It's on the revolutions of the heavenly spheres for us non-Latin speakers.
Oh, okay.
And it's considered like one of the most important works in the history of science.
Really?
What's wild is that Copernicus wasn't working with any brand new observations, really. He was mostly just driven by this idea that there had to be a simpler, more elegant way to understand the universe than all those convoluted epicycles.
So he basically just thought Ptolemy's model was too messy.
Pretty much.
Okay.
And you know what?
No.
He was right.
Okay.
His heliocentric model, it explained things like retrograde motion in a much more straightforward way.
Oh, okay.
Instead of planets doing those weird loop-de-loops, you know.
Yeah.
The apparent backward motion could be explained by the fact that Earth and other planets are all moving around the sun at different speeds.
Okay.
So as the Earth overtakes another planet in its orbit, it looks like that planet is moving backward for a while, even though it's not really.
Okay, that actually makes a lot of sense.
Right.
So if Copernicus's model was simpler and explained things better, why didn't everyone just jump on board?
Well, imagine trying to convince people that the ground beneath their feet wasn't actually standing still.
I mean, yeah.
It went against, like, everything they experienced and believed.
You don't feel the Earth moving.
Exactly. So the idea that we were actually hurtling through space around the sun was pretty radical back then.
That makes sense.
Yeah.
Plus, didn't the church have some pretty strong opinions about Earth being, like, the center of creation?
Oh, absolutely. The church was a powerful force back then, and they weren't too keen on this new model that demoted Earth from its central position.
Yeah.
You know, Copernicus actually knew this.
Really?
Which is probably why he waited until just before his death to publish his book.
Smart move.
Yeah.
So was Copernicus's model immediately accepted by other scientists, at least?
Not really.
Okay.
Even though it was simpler and more elegant, it still lacked, like, definitive proof.
I see.
A lot of people saw it as more of a mathematical theory than a true reflection of reality.
Hmm?
It would take the work of another brilliant astronomer,
Oh.
Johannes Kepler,
Oh, right, Kepler.
to really solidify that heliocentric model.
Didn't he come up with some, like, important laws about planetary motion?
He did indeed. Kepler, he inherited this trove of incredibly detailed astronomical observations from another astronomer, Tycho Brahe.
Okay.
And he spent years painstakingly analyzing this data, searching for, like, patterns and relationships.
Oh.
He was driven by this belief in the mathematical harmony of the universe, and he was determined to, like, uncover the laws governing planetary motion.
That sounds like a lot of number crunching.
It was. So what did he actually discover?
Yeah. What did he find?
Well, first of all, he realized that planets don't actually move in perfect circles around the sun.
Really?
They move in ellipses,
Okay.
which are like slightly squashed circles.
Hmm.
This was a radical discovery because the circle had been considered like the perfect shape since ancient Greece.
Wow.
So planets are kind of doing this cosmic dance around the sun, not just moving in simple circles.
The cosmic dance, I like that.
And his second law, it explains how this dance works. He found that a line connecting a planet to the sun, it sweeps out equal areas in equal time intervals.
Oh.
What this means is that a planet moves faster when it's closer to the sun and slower when it's farther away. It's kind of like, you know, a cosmic waltz,
Ooh.
with the planets speeding up and slowing down as they twirl around the sun.
That's a great analogy. So
Yeah.
2 laws down, what's the third one about?
His third law established this precise mathematical relationship between a planet's orbital period, that's the time it takes to complete one lap around the sun, and its average distance from the sun.
Okay, so all this math,
Hmm.
I'm guessing it was pretty important.
Oh, it was a game changer. Kepler's laws not only confirmed that the sun was indeed the center of the solar system,
Right.
but they also gave astronomers this ability to predict the positions of planets with incredible accuracy,
Right.
a level of precision that Ptolemy's model could only dream of achieving.
So with Kepler's laws, the heliocentric model was finally proven beyond a doubt. Case closed.
Well, the mathematical support was strong, but there was still something missing. Direct observational evidence.
Nah.
And that's where Galilei comes in. He pointed his newly invented telescope toward the heavens and made discoveries that would forever change our understanding of the universe.
Okay, so we've got the math from Copernicus and Kepler. What did Galileo see through his telescope that was so groundbreaking?
Well, one of his most important discoveries was observing the phases of Venus.
Venus has phases.
You see, Venus goes through phases just like our moon,
Oh, okay.
but the way these phases appeared could only be explained if Venus was orbiting the sun, not the Earth.
So that was like visual proof that Venus wasn't just like dancing around the Earth.
Exactly. He also discovered 4 moons orbiting Jupiter, demonstrating that Earth wasn't the only center of motion in the universe.
Right.
This was a huge blow to the geocentric model,
Yeah.
which assumed that everything revolved around the Earth.
So Galileo was basically providing like visual evidence to support what Copernicus and Kepler had already figured out mathematically.
Precisely. And when he published his findings in 1610 in a book called Sidereus Nuncius, which means starry messenger, it caused a huge sensation.
Wow.
It was like he was sending this message from the cosmos, challenging that Earth-centered view that had reigned for so long.
So if Galileo's observations were so convincing, why do we always hear about him getting into trouble with the church?
Well, unfortunately, Galileo's discoveries and his outspoken support for the Copernican system put him in direct conflict with the Catholic Church,
Right.
which still very much held firm to that geocentric view.
Yikes. That doesn't sound good.
It wasn't. He was eventually put on trial for heresy and forced to recant his views.
Wow.
It's a pretty tragic story, but also a powerful reminder that scientific progress isn't always a smooth or easy path.
Yeah. It also makes you wonder how many other, like, groundbreaking ideas were just silenced throughout history because they challenged the status quo.
That's a great point, something to think about. But despite the challenges he faced, Galileo's observations had a profound impact. They really helped to shift scientific opinion decisively in favor of the heliocentric model.
Okay.
By the middle of the 17th century, most scientists had accepted that the sun, not the Earth, was the center of the solar system.
Okay, so the heliocentric model is finally winning the day. But I have a question. If the Earth is orbiting the sun, what's keeping it from just flying off into space? What's holding it in orbit?
That's a great question, and it leads us to one of the most brilliant minds in history, Isaac Newton.
So we've got Copernicus moving the sun to the center,
Right.
Kepler figuring out the math of planetary motion,
The math.
and Galileo providing visual proof. But, like, what's the force behind all this? That's where Newton comes in.
Exactly. Newton. Total rock star of science.
Oh, yeah.
He came up with the law of universal gravitation,
Okay.
which basically explains why planets orbit the sun in the first place.
Okay, so how does that work?
Well, this law says that every object in the universe attracts every other object.
Wait, really?
Yeah, with a force that depends on their masses and how far apart they are.
Hold on. So is this the same force that makes, like, my coffee cup fall off my desk when I'm not careful?
You got it.
No way.
The very same force that makes an apple fall from a tree
Wow.
also keeps the moon in orbit around the Earth and the Earth in orbit around the sun.
It's kind of wild to think about.
It is.
This one law governs everything from the motion of planets to the tides on our beaches.
Pretty amazing, right?
That's like poetic almost.
I know.
The universe has this underlying order to it,
It does.
this beautiful interconnectedness.
It's one of the things that makes studying science so captivating.
Totally.
So with Newton's work, the heliocentric revolution really reached its peak.
Okay.
We finally had this complete and elegant explanation for how and why celestial bodies move the way they do.
So we've gone from this Earth-centered universe where planets were thought to be on these, like, crazy epicycle roller coasters
I know.
to this sun-centered system
Right.
governed by these, like, elegant laws of physics. It's just amazing how much our understanding of the universe has changed, you know?
What's even more incredible to me is that this shift from a geocentric to a heliocentric view,
Yeah.
it wasn't just a scientific revolution.
Yeah.
It was a philosophical one, too.
Right.
We went from thinking we were at the very center of everything
Right.
to realizing we're just inhabitants of this tiny planet orbiting an average star in this vast, maybe even infinite cosmos.
It's humbling. Right.
It is, but it's also incredibly exciting.
Yeah.
The heliocentric revolution paved the way for modern astronomy with its mind-blowing discoveries of galaxies, nebulae, black holes, the fact that the universe itself is expanding.
It's like opening a door to a whole new realm of possibilities.
I know.
And it's all thanks to those early astronomers who just kept looking up, trying to make sense of those twinkling lights in the night sky.
Yeah.
They were so curious, so persistent, so willing to question everything they thought they knew.
And that led to one of the most profound shifts in human understanding.
It really did. So where do we go from here? What are the big questions that are still out there waiting to be answered?
Well, now that we know our place in the solar system, how does that inform our search for life elsewhere in the universe?
That's a big one.
It is. If our planet orbiting an ordinary star can harbor life, what are the chances that other planets around other stars might be teeming with life too?
Wow.
It's a question that continues to drive scientific exploration and, ignite our imaginations.
That's a pretty amazing thought. We're not just figuring out the mechanics of the universe,
Yeah.
but we're also exploring the possibility of other life out there.
Exactly.
It's just incredible how far we've come, from those first sky watchers to pondering the existence of aliens.
It's a wild ride.
It really is. It shows the power of human curiosity, I think.
Absolutely. And who knows what incredible discoveries await us in the future, right? This journey of cosmic understanding is far from over.
That's for sure. This has been The Deep Dive, and we hope you've enjoyed this exploration of planetary motion.
Thanks for listening.
We'll see you next time for another deep dive into the depths of knowledge. Until then, keep looking up and keep wondering.